welcome to the EO Roundtable series where we speak to optics experts about trends that are impacting our industry and beyond. I'm your host, Scott Bass, and today we will continue with our topic on additive manufacturing. Additive manufacturing encompasses many technologies from 3D printing to rapid prototyping and other layered manufacturing and additive fabrication techniques. I'm back with some of our own Edmund optics experts to share their insights on how additive manufacturing is shaping our industry and more. For part 2 of this topic, our experts will discuss the impact of 3D printing on IP protection, the future of additive manufacturing, and how additive manufacturing and automation impact the job market. Let me just ask you, how is 3D printing impacting IP protection, cybersecurity, things like that?
Well, when you can take something and just scan it to reverse engineer it and print it, I think that's really a game changer. You know, it's no longer trying to, take something, take it apart, see how it's kind of fitting together, and create a print from that. With the scanning technology growing in its precision alongside the 3D printing technology, I think that really is a huge IP concern, and then something that you kind of need to be made aware of when you're making something, understanding that if someone can reverse engineer it just by scanning it, then that could be an issue.
But what about all the internal features?
It's true.
Shadows and casts and stuff like that. I mean, the real intricate stuff still has to be reverse engineered the old-fashioned way, I guess. But yeah, I think the hackability, I guess, is something that would concern me. If I have this file and I've been 3D printing it and making money off of it, and if you don't have your cybersecurity up to snuff and somebody comes and gets your files, then I guess it's always kind of concerned. But if you have a 3D printer, you're that much quicker.
Right. It's a lot easier than, if somebody hacks in your PDFs of your manufacturing prints. They're still digital, but somebody still has to know how to read a manufacturing print and has the machinery for it.
And the person with 20 years experience on that machine.
Sure, exactly. So yeah, hackability is a good term. There, you have everything right there, and if you have a machine that can print it, there's no skill really required once you've attained a file.
I think it's going to need a whole cultural shift. I mean, are we as a company going to go out and sue Bob in his garage who printed up a copy? Like, no, of course not, right? So there needs to be, I think, not just legally, but culturally, it needs to be some awareness that, like, yeah, these things matter. IP is worth something, and you shouldn't just steal ideas. One that's really common now in China that I've been hearing about is, you'll see, like, a couple years ago, those hoverboards where it's like 2 wheels that you stand on and kind of ride around. That wasn't one guy's invention. That was like 30 people's invention, where they passed this idea back and forth and improved it over time, and then it just sort of appeared. And that's a pretty common cultural thing in China lately, in the kind of high-tech world. And so, like, that's, I think, starting to find its way over here, especially with 3D printing. So, we have to sort of build awareness that, like, somebody's idea is valuable to them and you shouldn't steal it.
But it's okay for Bob to do this in his garage, though.
Maybe.
You hear that, Bob? You got the green light.
Well, and in a lot of cases, 3D printing is just making customization accessible to a much wider audience, because you don't have to have 20 years machining experience and know exactly when that lathe is humming a certain way that you're getting a certain finish out of it. You can just kind of, through trial and error, generally get at what you're trying to do, and so it's both a blessing and a curse.
So technology is just going to advance so much quicker because of this now, right? Where people could just jump right into this and do things that would have taken years.
I would think so. Have you ever tried it?
I have not, but I am fascinated, for sure.
What do you want? We'll 3D print it for you next week.
I want a G.I. Joe action figure.
We're aware.
Of course you do.
We're very aware.
Do we have a counter for how many times he says G.I. Joe today?
Or,
That's more at 2.
Optimus Prime, perhaps?
Yeah, Optimus Prime.
Well, on the note, outside of optics, I know we're talking about optics, what are some interesting things that have, really given you some inspiration of what could be 3D printed?
Yeah, so for me, GE went and 3D printed an entire jet engine. Right, I mean, mostly metal, not glass, right? But still, I mean, literally a functional jet engine.
The insides too?
The insides too, the whole 9 yards. So to be able to get to that level of precision that you can make something like that operates at high temperature and all these other things, that kind of says, like, yeah, the future's sort of now.
Certainly the powder metallurgy that companies like DMG can offer. I mean, we were shopping for an ultrasonic mill that we have a couple of now. But in that same showroom was this very large piece of equipment where you have metal powder flying out of a nozzle with lasers, and you're basically just able to in real time build up a 3D printed metal object quite quickly, and that's where you're getting some of these.
Yeah. Make a turbine from nothing,
turbine blades and things like that.
Yeah. It's crazy.
I saw a presentation in Tucson, and there's a company that is, among other things, working on doing tourist trips up into like lower or upper Earth atmosphere trips, and they were working on sending somebody up and breaking records, but they were talking about the process that they heavily relied on 3D printing, where they were doing design iterations in the morning, sending them out for 3D printing, and then trying it the next day. So they were having 1 day turnaround on different ideas in terms of fixturing for all sorts of things. And this was going in high velocities and under extreme conditions. And but just seeing how somebody could take that, and every day you're iterating and learning from the day before. You're not waiting 4 to 6 weeks for a metal vendor to make something.
Sure.
So it shifts your thinking as an engineer in terms of what's a realistic time frame.
Yeah, they're
and
doing
what
some
trade-offs.
big things now too. A friend of mine at DSM that works in 3D printing they're making the aerodynamic panels for F1 race cars, and they'll actually put that printed part on the car and test it, rather than having to do so much of the iteration in the computer. To just get it out on the track and see what it does, and they'll actually use that printed part as is, and those are obviously huge.
Skipping that design phase.
Right, basically
Again,
skipping the
right.
design phase, yeah.
You know what kind of strength testing they may have done on the base material? 'Cause it
Not
seems
really
like some of the forces are.
You'd think so, yeah. I know they've done some work on the material, but I'm not sure what kind of testing is involved other than racing it.
Yeah, well, it's the ultimate test.
Right.
I mean, the biomedical applications are still the ones that they kind of fascinate me the most. To think that we could be at the point where you don't need to get a kidney transplant. Someone can just take your
Print you a new
kidney
one.
cells and
Right.
and print you an entirely
amazing.
What a world we live in
new
today.
organ,
Yeah, right.
right?
Well, and it's
Is,
especially applicable because everybody's a little different, right? So you've
That's
got
right.
to adapt it to their particular, anatomy, and that's, obviously way better an application than trying to do something serial production in some factory somewhere.
Yeah, I guess I still go back to the one that gets me is just field medicine and stuff like that, being able to print a splint or a cast or something like that. It almost looks
Right
like a
then and
spider
there.
web, on their arms by the time they're done. And
That's straight
just
out of
being
a
able to-
movie, huh?
Yeah, but just being able to
Yeah.
do that in remote areas
Yeah.
or something like that quite quickly without having to have the facilities to do casts and all of those types of things. It's hugely impactful.
Yeah, it forces you to start changing your expectations in terms of what something looks like. So for a cast, you think of this big plastered white
right,
part, but that's a function of how we treat it, and all of a sudden you have to think about what's the function of the cast, what is the minimum strength or material requirements. Now you have this web, so I think in engineering it
Finally
forces
get
you.
at that itchy spot.
Yeah. Yeah, right. You finally, you have to start revamping what truly does it need to be, as opposed to, well, this is what it's looked like in the past. That's a function of the manufacturing, not the needs of the application. So it kind of forces you to break some preconceived notions in engineering. You see that a lot with lightweighting. A lot of these applications where you need lightweighting, it's too much machine time to start putting holes and cells and things to remove material.
But you can easily 3D print
But with
something
3D
like
printing,
In fact,
yeah.
it saves time, right? Because you have less material.
Because you have less
That's
material.
right.
So
So as seasoned, experienced engineers, how do you stay fresh with all this? What do you have to do to keep up with these latest
interns.
trends? I mean,
I think that's telling, because the interns are coming in with 3D printing experience
Oh, yeah.
and knowledge, even more so than some folks who've been around for a while. And yeah, some of the stuff you do pick up from interns.
Yeah, so-and-so's done, an internship previously at NIST or whatever, and has already dealt with this in the past, and you learn a lot from that.
Well, just the sheer volume of scholarly articles that are published. You spend a good amount of my week sitting in it and reading abstracts, and then one looks good, then you dig down to the next level, and then scan through it and circulate it to the groups that might be interested, and then they tend to crunch the numbers a bit more and come back with proposals. And so, I mean, that's a significant portion of my job, I would say, is scanning through those, and then similarly going to conferences where
Trade
you can
shows,
sit there and
exhibitions,
folks will
every conference
chat
has
about
its own
what they're doing.
flavor. Then you kind of get a feel for where everyone's the buzzwords and the booths where everyone's going to. And
then it's the door-to-door 3D printer guy.
Demonstrate the vacuum and the 3D printer.
Right, they come in
Formerly
and
with
they give
Avon.
a spiel on you know, what it can do, what it can't do, and what we could use it for. And you know, I would imagine that eventually that the market would kind of you know, some of these smaller companies may not exist anymore.
Yeah, sure.
And
Sure.
yeah, consolidate into a couple of just large names in the technology, and then they'll be a little easier to track on the developments and the improvements on the technology when that happens.
It's an interesting time to be an engineer, huh? I mean, it's forcing a lot of you to kind of relearn and re-envision the way you do things, and some engineers won't look ahead, and right, it's kind of a turning point for you as an engineer, right? It's either you're gonna just continue what you're doing and maybe be in denial of some things, or just really embrace it, and like you said, you're doing the research.
I mean, we're talking technology advances. Engineers are going to embrace that.
Yeah.
I think.
The good engineers.
Yeah, right.
And you know, I'm a Trekkie, right? So I can't wait till we get to the point where you know, you've got your 3D printer, and you know, you can print that cup or whatever other thing around the house that you want to do. That's just one step closer to actually getting a replicator.
Earl Grey.
he's just got a hand on the
He's got the
counter
head
that's
for
just
that.
like he rotates it around.
Well, computer is now Alexa, right?
That's right.
Yeah, that's right.
But I think you can start incorporating that. You don't need to just like go whole hog. Okay, I'm just going to 3D print an entire optical system. But you can start looking at components or things like what we're doing now, where we're looking at, you know, moving it into the manufacturing process. Maybe not the optic, but maybe fixturing or tooling or things like that. Start to kind of get a feel for how it works. I mean, there's things you can do with that you just can't make any other way.
Right.
And maybe those are useful to you in your, you know, in other aspects of the optomechanical design. So there's places you can start to pull it in now.
In costs for 3D printing equipment and materials, they've been
Various
rising,
very
shrinking.
wide,
Like what's
it's a
the
wide spectrum.
Yeah.
It's a real wide spectrum. You can get a 3D printer now for less than $1,000.
Yeah.
Or you can pay 6 figures, 7 figures,
Depending on
depending on what it is you're
Yeah,
trying to
there's
do.
always that kind of crossover chart where you look at what volume you're doing, what complexity you're doing, what's the process, and you kind of always have that crossover point where you have traditional manufacturing is still going to be cost effective, and the point where it crosses over with the additive manufacturing. So I think it's highly dependent on the process and the part. I think in terms of keeping up on the new advances, I think one of the important things is looking at other industries that not even just tangential industries to optics, but completely outside optics, because it's not like the tech industry or high-tech industry is the only one using 3D printing. You're talking about 3D printing toys. I don't think we typically take our cues from, you know, like mass production lines at Target, but, you know, you see some of the technology coming out, or, you know, robotics on production lines, and it starts getting you thinking about how that can apply to the optics industry. So I think that's another way that it's sometimes harder to tie together, but, you know, you see a cool YouTube video and send it around. You have a few clever people and think, oh, we can do this. We can do this here, and you know, that's how things move forward.
Right.
So you've heard of robots making robots. Well, having
3D printers making 3D printers.
I wasn't going to go there.
It's called RepRap, and it exists.
Yeah.
But you know, with the lens components inside some of 3D printers, particularly if they're using an energetic source to lay down the printing, then you do have, you know, optics, creating optics within 3D printing.
You like
Skynet.
optics? We put some optics in the optics.
Love it. Though, I mean, that brings up the whole topic of, you know, lights out manufacturing and automation, you know, and displacing jobs and things like that. That's also something that I think everybody's acutely aware of these days is, you know, yeah, you see all this manufacturing coming back into the U.S., but it's not creating as many jobs as it used to. And why is that? It's because of things like this that can displace workers and stuff. So it's also, again, something, you know, that culturally kind of needs to build into some sort of awareness how exactly to do that. I've got no idea, but.
Right, it's about adapting and shifting. You know, you have a displaced workforce. You know, where does the retraining happen? Because it's not like any robotics or automation doesn't require hand-holding by, you know, a technician or an engineer. And so I think there's kind of the culture shift idea of, you know, there are jobs being created. It's just not
the same ones.
Not the same ones. You know, you're
And
creating
the same
a
number of them.
Right, exactly. Now you need people who know how to maintain software and, you know, robotics and automation equipment. You know, that's a whole new industry that you've created.
I mean, if you want your product to be highly successful, if it reduces the labor requirement of something, you know, that's always an attention getter for a lot of corporations. Just think of the next time you go to the grocery store, and you can either go in the line where there's someone at the cash register, or the self-checkout where there's one person and like 5 or 6 or 7 registers that they're just looking over.
Thank you, and I hope you enjoyed part 2 of our discussion on additive manufacturing. If you have any questions about today's topic or about the optics industry in general, please visit www.edmundoptics.com to access a wealth of free technical resources and ways to contact our engineering support team. Thank you again, and we look forward to hosting future roundtable discussions.